So Nikam is joined. Okay. So I'm going to share my screen. And how many have you implemented that MST in your production environment, guys? And having the knowledge on MST? I'm asking how many have you implemented the MST in the production environment? And you have the knowledge, right knowledge?
No, sir.
I have never seen, so I don't have any idea.
And before your last class, all of you I'm asking. I'm not asking one or two person. I'm asking to all my students over there. Your last class.
I have also not implemented ML.
Any last class which you anybody has already you have taken the CCNA class, right? And CCNA class they gave you that overview or not? They didn't cover that MST.
No,
They didn't cover the MST, sir.
no, sir.
Then in CCNA switching, what they covered? Nothing.
Only STP.
STP, only STP, sir.
STP क्या होता है?
Even not BPD guard or filter, UDLD, post fast.
Even I also studied STP and RTP.
STP or RSTP? Ayush?
Yes, that's only.
Say very clear, na? Your statement has to be very clear. Sir, I studied in CNA, STP, spanning tree protocol, and RSTP, rapid spanning tree protocol.
Yes.
I don't want yes, Ayush. You have to be very core in technical. What you studied, you remember the things. What is the meaning of that? What is the knowledge you gain over there? So motto is that the MST nobody is covered till now. Anybody have done that any CCNP training before that?
Yes.
Who done that CCNP training?
Mukesh.
Mukesh. Nobody covered anything, guys. Mukesh.
Only STP they covered.
Then what is the meaning of the CCNP class? It is a professional.
CCNP only OSPF, yeah, GFP and BGP they covered, sir. MPLS, ERF. That's it.
That's why it is a pressure for me, guys. When you're coming from the right background, then it is going to worth it. That is the main reason, guys. I'm worried about that. Last class, anybody not covered you properly. That is the big tension.
We are learning STP briefly in this class only, sir.
That is the problem, Nikam. If you are coming from the right background, then we have that right skill set, right? Otherwise, then I don't have any issue. Okay, let's be. We will go a little bit deeper, and if you don't have understanding, you let me know. Okay.
Thank you, sir.
Yes, sir.
Okay, guys, I'm going to share my screen. If you have any difficulty while understanding the MST, it is a deep discussion which I would like to give you. So basically, it is a in-core, and in-core is going to cover your professional part. Okay, and if deep dive part, if you have right now that BPT packet level of knowledge, you have, right? What contains in the BPT packet? It is a MAC and priority.
Priority.
Okay. Now coming to the Ethernet frame, when we're going to talk about this, sir, the MAC address is the 48 bits, and Ethernet frame, which is going to work into the layer 2, where we have the two mandatory fields, source MAC and destination MAC, right? So without VLAN tagging, what is the size of Ethernet frame, guys? If I have a 6 byte of source MAC, 6 byte of destination MAC, 6 plus 6 is equal to 12, right? I'm talking about the header size. Remove that, your payload and all, which we have more than 1400 bytes, right? So including only that Ethernet header size, 6 byte of the source MAC, 6 byte of destination MAC. Then if it is a trunk interface, then 4 bytes they are going to use for the tagging. So 6 plus 6 plus 4 is equal to 16 byte.
Sir, share the screen, sir.
No, I'm talking about blankly, and you have to catch my word.
Yes, that is the thing. That is the thing. I'm catching the word. Yeah.
I'm asking all of you, Abdul, can you talk something, or you are silent on the call? Are you there?
No, sir. I'm listening.
Okay. If you are listening, just you tell me what I talked about right now. Ethernet frame.
It's in the Mac, and we are talking about the bytes and all.
So what is that normal Ethernet header size? This thing is CCNA guys covered you, right? IP header size, Ethernet header size. Right?
Yeah, it's a little only.
Okay. So, and I am assuming nobody taught you nothing then. Right? The overall picture is that nobody taught you nothing.
Somehow.
Just give me 1 second, guys. Where is my pen, ma'am? My pen is vanished. Where is my pen? Where is my pen? If I'm going to share my screen, then pen is going to be visible. Where is the pen? All of you can see my screen, right?
Yes.
Guys, whatever you are getting from my side, you can keep in your brain till your death, right? You are committing me. Whatever you are learning from my side, you are not going to forget anything. You are committing, right? If you are not committing, then I am not going to deliver you.
No, sir.
Committing.
Committing. I'm committing, sir.
Simply giving you, and you forget after the 6 months, and again you are blank, then there is no point to teaching you always, right?
Yes.
The things which I'm delivered you are practically implemented in this world, and in this way the network is working. If you go in industry, you are going to implement the same changes as per the company requirement. By taking my knowledge, it is going to work 100%. This should always there. I'm not denying that while configuring the things, you are not going to do mistake. Mistake is the nature of the human being. People will do the mistake. From the mistake, you are going to learn the things more deeply. Right? Nobody is perfect. Oh, I'm looking for my digital pen. Just my pen. Guys, anybody? Now when we are going to talk about the Ethernet header, that we know that MAC address is the 6 byte, right? All of you, Nikam, all of you. So 1 byte is equal to 8 bits. 8 multiplied by 6 is equal to 48. So 48 bits is the size of MAC, right? So 6 byte of the source MAC, 6 byte of the destination MAC. And the third part is we are going to keep for the Ethernet frame. If any frame is passing through the trunk interface, which having encapsulation .1Q, it is going to add 4 byte of header. So what is the normal size? 12 to 16.
16.
This you are going to keep, remember, byte of the normal Ethernet header. I'm excluding the payload. Now coming to that layer 3 IP header, we know that 32 bits is equal to 4 byte of source IP address. We know that the source IP is a 32 bits, right? 8 4 ja 32, right? So when I'm writing that IP address 192.168.1.1, it is going to divide into 32 bits. Yes or no?
Yes, sir.
Each octet we have a 8 bits, 8 bits, 8 bits, and 8 bits.
8
It's
bits.
all together 32 bits. So source is taking in layer 3. I'm talking about layer 3 header. So source is how much? 4 byte of source,
Source IP.
4 byte of
Source IP.
destination
Destination
IP.
IP.
Now remaining we have that your layer 3 checks and all, right? Layer 3 checks and all. So FCS they have the prevalent and all. So mainly that this including header we are going to consider as a 20 bytes. How many? 20 bytes. But 4 plus 4 8. Rest of the thing you have that your FCS check, right? Layer 3 prevalence you have, right? So all together we have 20 bytes of header of layer 3. Make sense? Coming to the layer 4 where the TCP UDP is going to work, what is the size, guys?
20 bytes is minimum TCP header, sir.
What is there in TCP header? What extra we are going to add? Source port,
Destination port,
destination port.
and checksum will be there.
Checksum is
Right.
going to use. Checksum is going to use into layer 2, man. Don't tell that checksum is going to use over there. So then you have that TCP flags.
Flags and window size.
TCP flags you have.
Window size.
That flag. How many flags you have? TCP flag, sync,
Sync,
ACK.
SYNAC, ACK, push,
Sync,
urgent, fin,
in,
reset, RST, reset.
RST.
Reset.
Total 7 flags, I guess, sir.
Not guess. I need exact answer. There are the 6 flags only. Sync, ACK, pin, RST, then push.
Urgent and push.
Now, if this flag you are looking for that, right? Sync you have S, A, F, R, push, then U. Anybody remember that any flag is somewhere is it is to overlapping, and anywhere you see that this same flag we are going to use that. Urgent is a pointer or urgent is a flag, guys? Sync is fine. Everybody agree, right? Sync is a flag. ACK is a flag. In is a flag. RST is a flag. Push is a flag. Then urgent is a pointer or the flag?
It's actually a flag, okay, but we use it with a urgent pointer field in the TCP header.
So we have the 6 flag over there. How many flag?
6.
6.
Don't get confused with that sync plus ACK.
Okay, sir.
It is not a flag because when you are going to send the sync packet to the destination is replying with your own sync as well as it's saying that I got your packet. For that, I'm going to acknowledgement you. So this acknowledgement for receiving your packet plus I'm going to sync my sync packet.
Okay.
Then it is a plus. It is my own sync packet as well as I'm going to acknowledgement you your sync packet I received. Done. So TCP, you have the source port, destination port, you have a TCP flag. Then there is a guys MTU. Which layer is working? MTU
Layer 2,
layer 3.
layer
MTU is working. Layer 3. So assembling and reassembling and bifurcation is all happening into that layer 3 only. MTU just a packet size, right? So packet size is going to work layer 3 or layer 4, guys. Layer 4 all belongs to your application or belongs to your application which is related to your port, source port, destination port, and then you have a TCP flag. MTU is going to work on the layer 3. So it is a number of the byte of size, and if you are not going to say anything to the L3 device, by default maximum packet size, how much it is going to forward? 1500 byte. 1500 byte. Makes sense? In this 1500 byte, you have that your layer 2 frame is going to decapsulate by the layer 3 device, right? So in this frame, you have the TCP IP header, right? Inside that IP header, you have the payload, right? That IP header is going to encapsulate your TCP header. So last packet is the payload. On the top of that, you have the TCP header, and last one is that IP header. Last one is that IP header. So TCP header, where it is going? It is going inside your IP. Because TCP cannot be the outer header, right? How it is the outer header, guys? If it is IP header is over there, then you inside you have the payload. Suppose that payload we have a 1460 byte. IP header is the 20 byte and TCP header is 20 byte. When it is going to forward the packet, it will look that outer header only, right? So how the outer header, how that IP is going to contain over there? Never going to contain. So assembling the packet is doing like this. First the payload, which is going to encapsulate under that TCP header, which further is going to encapsulate under that IP header. If anything's behind that, then you have the Ethernet header is that outer part. Ethernet header is outer part. Make sense, guys? So last header is that L2. Between that router to the router, the communication is going to happening. It is a layer 2 communication. It is not a layer 3. Yes or no? Between the router, it is going to just switch the packet over there. It cannot route the packet over there. Reason is that it is just swapping that source IP, destination IP, source MAC and destination MAC. Inside your real IP header is fixed, but outer header, source MAC, destination MAC, source IP, destination IP, always going to change, right? So Ethernet header having a source MAC, destination MAC, source IP, destination IP. Inside IP header, you have the actual IP where the source and destination are. Yes or no? So this header is keep swapping between the router hop by hop. Hop by hop. So source IP of this, destination IP of this, source MAC of this, destination MAC of this. This is keep changing over there. At last it will go, it is remove this header, it will check that actual destination IP, check the route, it will go inside that. If it related to the application, that application is going to work. At the last, when it go to the node level, node is going to remove all the part because TCP already going to remove at the layer 4. Then it is layer 3 already removed. It will go to the switching layer 2. Inside the layer 2, we can see that our actual MAC address of the destination, and switch is going to forward the packet over there, and then we are going to get that payload. So this Ethernet header and LAN Ethernet header, have you doubt or it is picture is clear?
Clear, sir.
This header already removed at the layer 3. When it is going to reach to the last hop, this header already removed from there. It will check that IP address. it will look that when router is going to forward, now it is going to encapsulate the packet with that Ethernet header. Ethernet header. So encapsulation, decapsulation, last Ethernet header is going to do that. Layer 4 removed, this header is removed. Looking for the IP address, when it is forwarding the packet to the downward switch of the LAN, it is going to add that Ethernet header where that actual destination MAC, if you have, then fine. Otherwise, destination IP you have. Source IP, this IP you have source IP, right? And source MAC you have this one. It is an external Ethernet header. And IP of that actual destination IP of this, it is going to forward to the switch. Switch is look for the destination MAC address. It is going to forward to the packet to the node. Once the moment it is going to the node level, it is going to remove all the things. It is going to retrieve that payload. So this outer Ethernet header at this interface level, it is going to out. Looking that IP address, it is going to create the encapsulating under that Ethernet header. What is the destination IP? It is putting the destination IP. Do I know the MAC? I don't know the MAC. So MAC space is blank over there. So destination IP, destination MAC. Who is the source MAC? Source MAC is my gateway MAC and my gateway address. Yes or no? When it will go
One
to,
question.
yeah, please.
Sir, you said that Ethernet frame, okay, it contains like source and the destination MAC, and like you explained that whenever the packet traverses towards on the complete network, okay, the source IP and the destination IP inside the IP, okay, it never changes, right?
No, it is a real IP of the packet inside. So what is the real packet means? What is the real packet means? I have one router over there. I have another router over there. I have a switch over there. And I have a one node over there. Done. I have a switch over there and I have a node over there. When it is moving towards, when this source having the IP 192.168.1.10 and it is moving towards that 192.168.2.10. Guys, listen very carefully. This source MAC having a AA, this destination MAC having a BB. This MAC having a CC, this MAC having a DD. This MAC having a EE and this MAC having a FF. Okay, done. Now, when this packet is going to initiate, as it want to go to the different network, it is going to send to that gateway. Yes or no? So when packet is going to forward up to the router, router can see that Ethernet header, which having the source IP. What the source IP I have, guys? I have a source IP 192.168.1.10, right? Where it want to go, destination IP which we have 2.10, right? Source IP, destination IP. Now, what MAC I have? So MAC, source MAC I have AA. What destination MAC I have? I don't know. So it is a blank. Make sense? Inside that, you have this is your IP header. So this is your IP header and then you have a Ethernet header. So MAC is going to come over there. So we are going to shifting over there. Source MAC and here I have a destination MAC. So this AA, I'm going to put it over there, and as it is a different network, I cannot resolve that MAC because MAC we are going to resolve with the same broadcast domain, right? I'm not able to resolve this MAC, so it is a X6. Done. I know the source, I know the destination. Done. Now inside that we have a payload. We have a payload. This is the complete picture of your Ethernet header, where we have the source MAC, destination MAC, and inside that you have the real IP header, where you have the source IP, destination IP, and inside that you have a payload. Picture is clear or not yet? Some files also there, we have the FCS file checksum. That is a different field of the Ethernet header. When this packet will go over there, right? When the packet will go over there, this destination IP is going to replace with that gateway IP, yes or no? When I don't know that, then I have that field called gateway IP and gateway MAC, yes or no? Destination IP is still blank, and I have that gateway MAC and gateway IP. Done? Yes or no? Gateway
Yes.
IP and gateway MAC. Now when the packet will go over there, what router will do? External header it is going to remove. I don't want to see any L2. Done? Now what it will do that real source and destination is not going to change, payload is not going to change, right? This header all remove. So what I have? Source IP, destination IP, payload. When it is going to the gateway, it is saying that it belongs to me. Now, as I am a L3 device, I am going to check the route for 192.168.2.10, and it is saying that my next hop IP is router 2. My next hop IP is that router 2. As it belongs to the same broadcast domain, it is going to add a new Ethernet header. In that new Ethernet header, this subnet belongs to, let's assume that 172.16.1.10, and this IP belongs to 172.16.1.20. Same broadcast domain. It belongs to the point-to-point connection. Same broadcast domain. So it is going to learn that MAC of your CC and DT both. Yes or no? It is a DT. So now Ethernet header, my source MAC is CC, destination MAC is DD, source IP is the 172.16.1.10, and destination IP is that 1.20. So in this way, hop by hop, it is going to change. It is going to change. This IP keep changing. Source MAC, destination MAC keep changing. Let's assume that it reached to that my last hop over here. Done. Once it will reach over there, this entire part is going to remove. Now, what I have? Source IP, destination IP, and payload. Yes or no? When a moment it is going to forward the packet over there in the local LAN, it is saying that this router is intelligent. This cable is connected to the Ethernet header, means my switching part. Now it is going to encapsulate the packet new one. What is going to put? Source MAC, my gateway MAC. Source IP, what is that? My gateway IP. Let's assume that it belongs to 2.10. My gateway is 192.168.2.1. Done? Source MAC, source IP. Now it will look at your actual destination IP 2.10. Yes or no? My IP, source IP, they put it 2.1. Now I need to move into the 2.10. I don't know that MAC of my destination. So what I will look at? My destination IP, I'm going to put as a 192.168.2.10. And destination MAC is blank over there, which initially it was there like that. Yes or no? Initial, that original source IP is untouched. Destination IP, they are putting 2.10. MAC, I don't know. And inside that, you have the payload. This part is clear or not, guys? Let me know. Source MAC, my gateway MAC. Source IP, my gateway IP. Right? Because I am forwarding the packet. I have the source. Where I need to go? 2.10. Where I need to go? 2.10. Destination IP? 2.10. Destination MAC, I don't know. Because the broadcast packet, I'm never going to reply. I'm going to reply for my unicast packet. Okay? So destination MAC, I don't know. Inside that, we have that real payload, right? And we are going to add the FCS. When it is coming to the switch doesn't know about that IP. It will look that destination MAC. And it is saying that for 2.10, I don't have the MAC in my MAC table. What is going to do that? It is going to broadcast, except this port, it is going to broadcast in all other port. When it is going to come to that my node is going to check that it belongs to my IP 2.10. It is asking my IP. So I'm going to reply with my MAC B. So switch is going to learn this MAC over this port and going to keep it trained to that your MAC table. So now this frame is going to replace with that B and B. Now switch is going to forward the packet to that node. So while forwarding the switch's packet to the node, right, when the packet will go to the node, it won't look for any IP over there. Right? It is going to look for that, your payload. Because it already checked that, right? This IP belongs to me and I'm replying with my MAC. So when it is going to come over there, it is going to blank over there and it is going to look for that payload only. when it is going to reply back to that your switch is going to see that from where it is coming. It is coming from that your gateway MAC. Now it is going to forward the packet happen. It is same way it is happening over there. When it is going to reply with that, it is going to reply with this one. Now this time, who is the destination, guys? 192, 168, 1.10. Yes or no? Now this time, who is the destination? Source become the destination, right? Yes or no?
Yes, sir.
Now, when it has become the destination, we will look for this MAC and it is going to get the entry and the return packet will go to the node. So your inside source and destination only going to be applicable when the source is sending the packet to the destination, then it is going to look over there by the router where I need to send the packet. I said that 2.10, so I don't know that. I'm going to switch the packet over that switch. Now switch will see that whether the entry for the MAC is there or not for the destination 2.10 is not there, it is going to broadcast it. Now once it will get the MAC, it is going to switch the packet to the node. And node in the Ethernet part, it cannot see anything over there, right? Node is going to see only that payload. So it is going to accept the payload. It is going to see that what services is running. It is going to provide the service. How the return packet will go? So return packet will go to that your where? Your gateway, right? 192.168.2.1, right? Now it will, when it is go over there, now it will check that actual IP of the source. What is the actual IP of source? 192.10.1.10, yes or no? Now it will see that it belongs to the different broadcast domain. I need to route the packet. What is the next of IP? Router 1 IP. What is that? 1.10. Source MAC is DD. Destination MAC is CC. Source IP is that 1.20. Destination IP is 1.10. In this way, it will go hop by hop. Last packet, the router, when it will do that, it will check that where I need to send the packet, I need to see that actual source IP. Who's the actual source IP? 192.168.1.10. Now it is going to add that Ethernet header. Removing that one, it will put that my MAC, which is that E. My gateway IP. What is the gateway IP, guys? Here 192, 10.1.10, right? Or 192.168, right? Here. What is this one?
Yes.
192.1.10. So it is 192.168.1.10. It is going to put one IP 192.168.1.10. Done. Source MAC, destination MAC, I don't know. Source IP I have put it there, right? Destination IP, I know that. 1.10. And MAC, I don't know. If I know, then I'm going to put that MAC as well. So now, once it will look that key, I don't know that, I'm going to switch the packet toward that switch. When it will go to the switch will go to the broadcast, it will get the MAC. And now, look at that destination MAC of 1.10, it is going to switch the packet toward the node. When it will come to the node, entire header, Ethernet header, it cannot see anything. Ethernet header doesn't know. IP header doesn't know. TCP header doesn't know. What he knows? A node only knows the ARP and that payload. It will strip the payload. It will check the payload, what is written over there. This is the entire way the flow looks like. Between the router to router, it is L2 communication. While before making the Ethernet header, it will check the route for actual destination. As it is belong to different broadcast domain or different subnet, I need to route the packet to the next home. Once it decided, it is going to encapsulate the Ethernet header. Payload your unchanged, Ethernet header keep changing. Actual source and destination IP, it is only going to take the place when it is this router or end router is going to route the packet over to there. Yes or no? Yes or no?
Yes.
Sir.
This is the entire packet flow of a L3 device as well as the L2. Picture is clear, guys, or still you have a gap in the doubt? You have a doubt in the gap.
It's clear, sir.
Gateway IP and gateway MAC always there. When you don't have that, when you want to talk to different subnet, when that a node is going to send the packet over there, in that packet, guys, source IP is node IP, which is 1.10. Source MAC, I know that. What my MAC? My MAC is A. Destination IP, I have 192.168.10. 2.10 different subnet. I don't know the MAC because it belongs to the different network. I cannot resolve that. I cannot resolve the ARP. That's why I'm routing the packet. After that, you always having that gateway MAC and gateway IP. So where I need to route? I need to route the packet towards the gateway. Yes or no? Because this reaching to the destination, I don't know how to reach that. So where I need to reach? I need to reach to that gateway. So I'm going to send in the packet to that gateway. Now it is a unicast packet. Packet directly will go to that router. And routers see that, okay, packet will come to that 192.168.1.1. It belongs to my IP gateway. I'm accepting that packet. I'm going to remove this part. It came to me, I checked, I removed this part. What is there in my packet? I have a source IP, actual source IP 1.10. Actual MAC, I have AA. Destination IP where I need to go, 192.168.2.10. Where I need to go, 2.10. MAC, I don't know, blank space, fine. Any other thing we have, they require a services and all. They require a 443 services. Okay, fine. So in the layer 4 header, 443 will go over there. So they remove that actual when it is going to come over there. They remove this part, gateway IP and gateway MAC, which I won't require anything. Now, when a moment L3 device is going to check that 2.10, as it is L3 device, always going to check the routing. As it is a unicast packet, it will check the 2.10, 2.10, it will check the routing entry. Routing entry is pointing towards the default route, a static route, pointing towards the R2. Once it decide that I need to do the routing towards the R2, now it is going to add that actual Ethernet header. Inside that, you have all those things. And inside that, you have that third block called payload. In this initial external header, you have the source MAC of this interface, which we are going to call as a CC. Destination MAC, we have a DD. Source IP, we have a 172.16.1.10. Destination IP have a 1.20. It is keep changing between the hope and hope. Last hope when it will go, and it will check that actual destination IP. It is going to strip entire part. So this entire header will go on. Inside that, what will come? Second header. The second header, what is there? Actual source, actual destination. Yes. So now, when the last it is going to reach over there, it will check the last destination 2.10, and now it will see that it is pointing towards that switch. Right? It is pointing towards the switch. Because the router is that it is going to doesn't understand that broadcast packet is going to always unicast packet. It will check the destination IP of the node .10 as it is learning from the switch. So it is going to send the packet toward that switch only. When it will go to the switch, switch will check that key. What is that? Destination MAC for that 2.10. If it is not available over there, it is going to broadcast it. It is going to resolve it. And now, once it will resolve, it is going to send towards that node. In the node level, I don't know the actual source. I don't know the actual source MAC, which is coming from here. As it belongs to destination 2.10, it is my IP. It is my IP is matching, my MAC is matching with. I'm going to accept the packet and I'm going to read that payload. The reverse packet will go into the same way. Now, when it is reaching to the router, it will check that actual source from where it is coming. It is down reverse packet become that my destination, right? 192.168.1.10 is my destination over there, right? Now, once it will look to the destination IP, it is saying that I'm learning from the switch. I'm going to send the packet over there. By keeping the source IP of the gateway, MAC over there, when it will go to the switch will check the MAC and it is going to switch the packet toward that, return packet toward that node. That's all. So entire.
Sir, can you go again destination, sir, from the server? It doesn't know server knows that the IP address is 10.1.10, sir. Return packet, reverse packet.
Reverse packet when it will go over there. As it is a router, it will check the actual destination. Who is the destination? 192.168.1.10. Yes or no?
Yeah, server will repacket that one and send back to the
Router.
router. Okay.
When the packet will go over there, it will check that from where it need to go. It need to go 192.168.1.10, right?
Yeah.
MAC address, I know that here over there. Yes or no?
Yeah. Yeah.
Now it will check that this MAC is learning from the switch.
Yeah.
Once it learning from the switch, it is going to switch the packet over there. In that condition, it is going to remove that your Ethernet header over there.
Yeah.
It is going to re-encapsulate the Ethernet header. In the Ethernet header, it having the MAC of the gateway MAC, source MAC of the gateway IP, destination IP is that 1.10, and MAC I know that AA, inside that you have a payload. What it is going to send to the switch is going to send the Ethernet header, and it is going to say that, oh, okay, it belongs to the AA. If the entry is there, then fine. Otherwise, it is going to do the broadcast and get the entry from which port I'm learning, and it is going to switch the packet towards the node. Within the node level, it will go that it doesn't know the Ethernet header, it doesn't know the IP header, it doesn't know the TCP header. It only looking for that your payload. So it is going to read the payload and it is going to give the service. When first packet go over there in this router doesn't know that destination IP of MAC. Destination IP of MAC. So what it will do that, as it is connecting to the switch, right? And it is looking for that your destination MAC, the destination IP 2.10, it belongs to the same broadcast domain, right? Yes or no?
Yes.
It is going to switch the packet toward that switch. When the switch is going to receive the packet, now it will see that whether this 2.10 is there into the MAC table or not. If it is not there, it is going to broadcast in all the port of that particular VLAN which belongs to 2.10. Once it will go to this node, it is going to match with the own IP 2.10 matching. If it is matching, it is going to reply with own MAC BB. And that switch is going to read it from this port and put it in the MAC table. Now, after reading that one, the switch is going to send the packet towards. Now this time in the packet, BB is entered. BB is entered. Now the return packet when go over there, it is BB is written over there. And when it will go to that your R1 router, AA already there, it is coming from the switch is going to send the packet, and switch is going to see that from where it is sending to that node, and it is going to read the payload.
This first communication happens.
Yeah.
Okay. Yes, sir. Now it's clear, sir. I'm audible? Hello? Thank you.
Guys, the picture is clear or not? All of you. Entire packet flow picture is clear or not? It is a basic knowledge for the L3.
Yes, sir.
Yes, sir.
Joss, picture is clear or not?
Yes, it is clear. It's clear. Thanks, sir.
From the source to destination, I don't know the MAC. That place is blank. When the return packet will come, that MAC is going to fill it up. And always you have the Ethernet header between your two routers. So you cannot see in the interview panel between hope to hope, it is a layer 3 communication. No, sir. Between hope to hope, it is always a layer 2 communication, because the two router is a point-to-point connection. They know each other IP. It is part of the same broadcast domain. In the same broadcast domain, this never is a routing. There never would be the routing into the same subnet or same broadcast domain. So MAC is this, source IP is this interface, destination IP is this interface. It keeps switching the packet until unless the last packet will go to that router and it is see that from where it belongs to. It will check the actual destination IP. In your case, which I have given that 192.168.2.10, and it found that in 2.10 I have the route over there because it is my connected interface. So last router is going to decide 2.10 it belongs to me or not. If not belongs to me, it keeps switching the packet between hop to hop until unless last router comes to know that, hey man, where is the actual destination 2.10? It belongs to my connected subnet. Now, if it belongs to my connected subnet, I need to switch the packet over there. As a router is never understand the broadcast packet, it is going to unicast packet, it is going to route the packet. So once it look the 2.10, it is saying that 2.10 learning from this interface. I'm learning from this interface 2.10. It belongs to the same broadcast domain. I need to route the packet 2.10. Before routing the packet, it is going to decapsulation always happening into that L3 level. L2 level of switch cannot do encapsulation, decapsulation. So what the router is going to encapsulation? Decapsulation means it is going to remove that your L3 header, which you have the IP over there, and it is replaced with your MAC address. So it is going to build a new L2 header. Inside that you have that your real IP, whatever that L3 you have, it is untouched. Your payload is untouched. And then you are going to add the FCS. So this L2 header, when this router is going to add, it is going to put that own MAC of the gateway, source IP of the gateway IP, and destination IP they are putting for which you are the original L3 destination where you need to go. That IP is the destination IP and the MAC is blank. Now it will go to the switch. Switch will check the destination MAC. It is a blank, then it will look for the IP. Now it is going to put the broadcast for 2.10. When the broadcast return reply will come from the interface, it is going to add into that packet as well as it is going to add into that entry. In this packet right now, the MAC we have baby. Once the packet will go to that node is accepting that one, return packet will move into the same way. When it is reaching to the first hop of the R1, now R1 having that actual source as well and actual MAC as well. Yes or no? Which we have the AA and that IP was 192.168.1.10. Yes or no? So it has the MAC also, IP also. As it is going to route the packet because it's L3 device, it looking for the 1.10 it's coming from my connected interface. It is going to switch the packet over there with the new Ethernet header. When it go to the switch will check that 1.10 whether I have the entry or not. If I have the entry for A, I'm going to switch the packet to the node. And node is going to check the payload. This is how that entire communication is going to work. So Ethernet header is keep swapping. Actual IP header unchanged. Your source is unchanged. Your destination is unchanged. Always. Then you have the payload is unchanged. Ethernet header is keep swapping over that. In the Ethernet header, you have the source MAC also, destination MAC also, source IP also, destination IP also. Yes or no? In that layer 3 Ethernet header, you have the source MAC, destination MAC, source IP.
Destination IP. Yep.
It is keep swapping until unless it is swapping. When the last router is going to check the 2.10, it belongs to my connected interface. Now it is the final destination where I have the node, end node. Now it is going to swap the entire Ethernet header and it is going to replace with own gateway IP, own MAC, and then it will check the destination IP 2.10 and MAC is blank, or if it is there, then it is going to put the MAC over there. Now it is going to switch the packet toward the switch. Switch will check that BB entry or there or not. If it entry is there, then it is going to switch the packet toward the 2.10. Node will accept the packet. It will check the payload. That's all. This question asks me when I appear for L2 in the tag of Cisco. They ask me how the entire flow works. Hop by hop and what is there into the packet. MTU layer 3, assembling and bifurcation always happening in that layer 3 only. Means if you have MTU size of 1500 byte normal L3 packet, normal L3 interface, and you are sending the packet of 1504 byte, then one packet will go as a 1500 byte, another packet they are going to bifurcate, it is going to keep the 4 byte over there. So 2 packet while leaving from this L3 interface, it having the 2 packet. So what is this one? Bifurcation of that packet. When it go to that your next L3 interface of the route, it is going to reassemble it. 1500 plus 4. Then it will check the total size of the packet 1500. It is going to process the packet. When it is leaving from the interface, it is saying that as maximum packet I'm going to allow for 1500 byte. Again it is going to bifurcate the packet. So reassembling where it is happening, ingress interface. Bifurcation where it is happening, egress interface.
Yes.
Make sense, guys? Yes or no?
Yes, sir.
That's why whenever you are going to ping a node in that layer 2, when you are going to ping that one, any node, it is not going to ping you. Are you getting my point? So the scenario is like this. If I have a one switch over there, guys listen very carefully, which I gave you the example of Q and Q. Just concentrate over there, Q and Q. When you have a one switch over there, when you have another switch over there, you have a one node connected over there, which is a part of the 192.168, 1.10, and another node which is sitting in a different bits with different site, and they belongs to the same broadcast domain, 192.168 and 1.20. In this node, when you are pinging 192.168.1.20, right? Then you are going to see the size as a 1500 byte, and you are seeing that DF bit. What is the DF bit means? Don't fragment it. So when the packet will go from this router to this switch is going to add extra 4 byte. Yes or no?
Yes.
So now what is the packet size right now? 1504.
Yes.
When it is going from this trunk interface L3, maximum packet, what is they allow? 1500 byte. And you are saying that you don't fragment the bit. So what is going to happen? It is going to drop over there while leaving from this switch. Yes or no?
Yeah.
Yes or no?
Yes, sir.
Yes.
It is my trunk interface. It is going to add my 4 byte extra. Yes or no? Yes, sir.
Yes.
You told me
Yes.
layer 3 Ethernet header, 6 byte plus 4. If it is a trunk interface, it's going to add the 4 byte of header for tagging the VLAN. Tagging the VLAN. Now the packet will go over there. It is saying that, man, I have a 1500 byte of packet. Now when it is going to cross over there, it becomes the 1504. Yes or no? It is going to add
Yes.
4 byte for. Now when a moment it is going to check that L3 header, it is saying that this packet is going to allow L3 level maximum 1500 byte. Maximum but 1500 byte. And I am saying that don't fragment it. If I'm not going to use this command, then by default what it is going to do that? It is going to fragment into 2 parts. 1500 plus
4.
then it is going to pass aram se. First packet will go, then second packet will go the 4 byte, aram se it will go, and it is going to reach to that node. When a moment I am going to say that 1500 byte, don't fragment it. So now automatically packet size, what is here, while entering it, ingress 1500 4.
1500.
Once it is automatically adding the header of 1504, now when it is going to cross the L3 layer, first is that layer 2, right? Layer 2 already added. Now it is going to cross the L3 header. L3 header saying that is a man, maximum 1500 byte I can transfer of you. Either you let me do to bifurcate this packet then I am able to do that. If you're saying that no, you pass as it is on the 1504 byte, I'm not able to do that. Maximum how much I can do? 1500. How much you are forcing me? 1504.
4.
Can I able to do that?
No.
Still you are not allowing me to don't fragment the packet. If you are not using this one, this 1500 byte, I can allow you the 2 packet and I will let you go. But you are forcing me, don't forget it and allow as it is 1504, which I cannot do that. So what is going to happen? Packet is going to drop. over
Drop.
there. Makes sense, guys?
Yes, sir.
So that's why while you're sending the packet, you should be very cautious. Right? So there is a tool called DF bit, which we generally going to use into the layer 2 technology or layer 3 technology to know that key what is the packet size maximum they are going to allow it. I have a one troubleshoot issue where I have a Palo Alto firewall over there, Palo, and through that Palo Alto it was the gateway, my Palo. And I have the core switch over there. Inside that core switch, I have a multiple access switches. So I have the 2 core switches over there where they are running the HSRP. Only the VRRP was there. And when they are saying that I don't have that login access to the Palo Alto firewall. I don't have the access to that Palo Alto firewall. I was into the issue. I never knows that this policy is going to allow into the firewall, yes or no. But at least sitting into that my node level, at least layer 3 issue I can detect it, yes or no. Forget about the layer 4. Whether the port is not allowed, where the policy is not allowed, it is all going to work at the layer 4, right? Firewall always going to work from layer 4 to layer 7. So sitting into this level, at least I can troubleshoot the issue of layer 3, yes or no. Core switch in front of me, access in front of me. Layer 3 issue I can resolve it, right or not?
Yes,
then
sir.
I use the tool called DF-bit and I throw a packet over there of a 1500 byte. And I say that don't fragment it. I say that don't fragment it. And it was, there is no trunk and all. So this packet, they allowed. As this packet was the jumbo frame, I keep saying the packet 9000 byte. I found that packet was dropped. Where is the issue, guys? Issue with that MTU of the Palo Alto interface. It is not allowing 9000 of jumbo frame, which was the requirement. This interface has to be allowed maximum MTU how much? Maximum MTU how much? 9K. Then I give that our logs to that Palo Alto guy. I'm saying that 9000 byte is not going to allow over there. There is a MTU issue into the Palo Alto. They set that MTU as a 9K, communication start working. Are you getting my point, guys?
Yes, sir.
9000 byte I send the packet and I've said that don't fragment it. Don't fragment it. If you don't fragment, then it has to cross the packet as it is, 9K only. It cannot bifurcate by default as a 15K, then 15K, then 1500, 6 times. Yes or no? It don't do that. Because there was that downside, that application, that they are not supporting the bifurcation, that application. So that is going to support the jumbo frame only. So Palo Alto guy, technical guy joined the call. He said that MTU, he captured the packet. He found that no, actually issue with that MTU only. So he set the MTU as a 9K, then communication start working. So there is also a tool that without logging to the device, how intelligently you are going to troubleshoot the issue. The tool called ping, destination IP, size, what are the size you need to send, and then space DF space bit, DF space bit. Yes or no? Right?
Yes, sir.
Now this is the overall L3 part which I gave you today and L2 part. Now we will start that MST. We will start that MST. Okay, just give me 5 minutes break. Let's have a one tea on my side. Then I will start my MST lab. Okay. MST entire picture I will give you how we are going to configure, what is the use of that, why is the ICST we are going to use that. Internal spanning tree protocol, it is going to always use into the edge switches, right? So MST always belong to a region. They have a specific revision number, they have a region name, and they have a same VLAN mapping into that particular region. These three criteria we are fulfilling to configure that MST. A MST region switch, if you have a multiple switches over there and they're running that same MST, that same instance of the MST. So instance, we can create the bundle of that, your VLAN, we can create a multiple instance, but running MST in a particular region, we have a three criteria. Name should be same, revision number should be same, and VLAN mapping exactly should be same in all the switches. Suppose that three VLAN you are going to bundle into the one instance, another 4 VLAN you are going to bundle into the second instance, same instance mapping you should have here also, here also. Then it is going to consider that this switch, all the switch belongs to that same domain or the same region. A switch which is going to connect to the different region where we have a different parameter and all, right? Suppose that is a normal switch, it is running in a different region, or it is a standalone switch which is running that STP and all. So this switch cannot see all the switches of the region. They are going to see one big switch into that region. So this switch having only one connection to that big switch, that is, they can see only one switch. Which switch? The edge switch. And what is running over there? They are going to see that they are running the ICST. What is that? Internal spanning tree. Internal spanning tree. Or CIST, we are going to say that common internal spanning tree. So we know that by default switch you are running the PVST, right? Yes or no?
Yes, sir.
So this PVSTP only going to recognize only one switch, and this switch is going to send that you.
all.
This switch, edge switch is going to say you there your instance and my instance also matching. So I'm going to say you that all the BPD packet which I have, but you don't know whether I'm running that MST or not in this region. What you know that I am going to run that PVSTP only, because IST means internal spanning tree is nothing but that it is running the per VLAN basis. It is running for that per VLAN basis. So your instance and my instance is matching. You never knows that whether I'm running the MST or not. Whether I'm running that MST or not, but details of whatever that MAC we are learning, whatever that I am learning over there, I'm going to pass you. I'm going to pass you. So external out of the region also switch, if I have one node over there and I have another node over there, can they communicate each other?
Yes.
Yes, because in this region they are running, it is interoperability. When the BPD packet will go, it is going for the instance of the IST or the CST. Both are the same form. Common internal spanning tree or internal spanning tree is the same name. So it is going to work as a per VLAN basis. So this MAC is going over there, and now once it will go over there, it has the capacity to interoperability between IST to the MST. Between IST to that MST. They can, because MST nothing but it is going to work with a per VLAN basis only, right? RSTP is going to work per VLAN basis only, right? So as that internal spanning tree is going to work on the per VLAN basis only, so they can communicate. Interoperability automatic is there. So whatever I'm learning into that this instance, I'm going to carry forward into that MST. I'm going to carry forward into MST. So this node can talk to this node easily, because sir, IST and MST can interoperability, they can communicate each other. IST nothing but sir, it is an internal spanning tree, or we can say that CIST common spanning tree protocol, internet spanning protocol, which is running on the per VLAN basis. MST also running on per VLAN basis only. So they can interoperability automatic is there because this switch, every switch, this is running by default. This is switch is running by default. Otherwise, something which is going to come from the outside, they cannot communicate each other. So parallel to that MST, by default instance is 0. That instant we are going to call as a IST, internal spanning tree protocol, which is going to use for that MST state 0. Any other customized one which is going to start from that MST 1 to
Sir, MST where they use, sir?
MST, multiple places we are using. Now the most of the industry using in the MST only because they don't want to use that your RSTP, they don't want to use as STP, right? MSTP is the per VLAN basis and it having that faster convergence rate.
Okay.
Why
Basically,
why they are using, if you have a multiple, suppose a 2000 VLAN if you have,
Oh,
if you're running that your RSTP, then you have a 2000 instance over there, yes or no?
yes, sir.
Which is unnecessarily going to choke your CPU. Running a 2000 instances per VLAN basis, you have a one spanning tree. Per VLAN basis, you have a one RSTP also running the per VLAN basis, right? So each VLAN basis one RSTP, each VLAN basis one. So you have a 12,000 instances they are running, and switch is calculating for each VLAN who is the root bridge, who is the non-root bridge, what is the port rule on, how they are going to bifurcation of that, your MAC address and all. So switch become overloaded. If we are 2000 VLAN and we know that out of that 1 to 500 VLAN, they have the same behavior, we are going to create a one instance. Then 501 to 1000, I'm going to create a second instance. 1001 to 2000, I'm going to create a third instance. So how many instances are running right now? 3 only.
3 instances.
So whatever the CPU and RAM you're going to utilize into that each instance, right now we are going to divide into only 3 instances, right?
Yeah.
So switch is going to behave more frequently, both reliability, right? Because it has the only 3 instances. You cannot look for each VLAN basis. I'm going to look for the bundle of the VLAN which belongs to the one instant, right? 1 to 500 VLAN, what is happening? It is going to consider as a
One instant.
500 to 1, whatever the MAC is coming, whatever the broadcast is coming for this VLAN and all, I'm going to consider as a second instance. And last one is the third instance. So now your CPU utilization is less, RAM utilization is less, and switch is more intelligently forwarding the packet, as well as you are very relief into the troubleshoot. The troubleshoot belongs to your instance only. Which instance having a problem? Either instance 2, 3, and 1. Once you identify instance 2 having a problem, then you can only look for the VLAN 501 to 1000 only. You cannot look that 1 to 500 and 1001 to 2000. Only
Not
you are looking
required.
for, not required, only required for this VLAN you are going to troubleshoot the issue.
Is there any criteria to bundle it? How to means when we bundle it, then there is a criteria.
Yeah, name.
It is having the 3 criteria that MST instance, whatever the instance you are bundling, it is the same instance you are bundling into all the switches. Your region name is has to be same, that is called MST name, and then you have a revision number. Then you have a revision number. Practically, I will show you over there because we have a lab. How we are going to configure, what things are need to do, everything I will show you. But after the break, just give me 5 minutes break or 10-15 minutes break. Then we can come back. What is the time right now? 11:34. We are going to finish now. So just we have a break for 10 minutes maximum. Routing I already started. Then little bit we are going to touch up that lab or that day 1 lab. Then we have that.